All right, let's jump right in. Today, we're going to talk about something that is literally reshaping our world as we speak, the rapid melting of our planet's ice. It's a process that's already changing everything, and as we're about to see, the latest science suggests the future could be far more dramatic than any of us ever imagined.
Let's start with a number, 20 feet. Just think about that for a second. That's about the height of a two-story building. And according to some pretty recent scientific research, that's how much our global sea levels could rise by the end of this century. It's a shocking figure, almost hard to wrap your head around.
So you gotta ask, right? Is this for real? Could our world truly be headed for a future where coastlines are just redrawn and major cities are under serious threat? To find out, we have to dig into what the science is telling us right now.
Now, I know what you might be thinking. You've probably heard other lower numbers thrown around before, and you'd be right. But here's the thing. Our understanding of the climate is changing incredibly fast. The predictions that a lot of us grew up with, well, they're now considered dangerously out of date.
And this is the crucial point. You see, back in 2001, official scenarios predicted maybe 3 feet of sea level rise. But that was based on research from the 90s. With new satellite data and a much deeper understanding of how ice actually melts, scientists have been forced to make a dramatic revision. We're now looking at a potential rise of up to 20 feet. That's not a small adjustment. That's a total game changer.
Okay, so where is all this water actually coming from? We're going to investigate the two main epicenters of this global meltdown, Greenland and Antarctica. And what's really fascinating is that even though they're both melting at alarming rates, they're doing it for completely different reasons.
Yeah, the melting is driven by two totally distinct mechanisms. In Greenland, warmer temps are creating these huge pools of meltwater on the surface. That water drains down through cracks and gets underneath the ice sheet. It acts like a lubricant, basically letting these massive rivers of ice slide much faster into the ocean. But Antarctica? That's a whole different story. There, the meltwater seeps inside the ice, into smaller cracks. Then it refreezes and expands, like a water bottle you forgot in the freezer, and it literally shatters the ice shelf from the inside out. It's a process called hydrofracturing, and it's incredibly destructive.
And the data coming out of Greenland is just staggering. Since 1990, the average winter temperatures there have risen by a mind-boggling 46 degrees Fahrenheit. The ice sheet is now losing 20% more mass than it gets from new snow each year. The whole system is completely out of balance. And the consequence of that is staggering. If all of Greenland's ice were to melt, it holds enough water to raise global sea levels by 23 feet all on its own.
This quote from a NASA scientist really captures the shock of what's happening down in Antarctica. The Larsen B ice shelf, a sheet of ice that had been stable for 10,000 years, completely disintegrated in just 3 weeks. It didn't just melt away. Scientists watched on satellite as it literally exploded.
So, the big question is any of this normal? To figure that out, we need to look back in time. And amazingly, the ice itself holds the clues. By drilling deep into the ice sheets, scientists can pull up these things called ice cores that are basically time machines, giving us a perfect record of Earth's climate history. For hundreds of thousands of years, Earth has followed this natural rhythm, driven by its orbit around the Sun. This timeline shows how that orbit changes in a 100,000-year cycle, and that triggers these long ice ages, followed by shorter, warmer periods called interglacials. This is the planet's natural heartbeat.
Now, when scientists analyze the little air bubbles that are trapped in that ancient ice, they find something remarkable. What they see is that for at least 400,000 years, atmospheric CO2 and global temperature have been perfect twins. When one goes up, the other goes up. When one goes down, the other follows. It's one of the most fundamental relationships in climate science.
Which brings us to today, and this chart shows the moment the story completely changes. For millennia, the planet's CO2 level stayed below 300 parts per million. Then, the Industrial Revolution happened, and we've pushed it way past 420. We have broken the natural cycle. There is simply no question that we have fundamentally changed our atmosphere.
And here's where it gets really concerning. This extra warming isn't just a one-off event. It's triggering a powerful feedback loop, a kind of vicious cycle that could cause the warming to accelerate all on its own. So the key to understanding this is a concept called albedo. It's just a fancy word for how much sunlight a surface reflects. Think of it like wearing a white shirt versus a black shirt on a sunny day. The white shirt reflects heat, right? It keeps you cool. The black shirt absorbs it, making you warmer. Well, the Earth works the same way. Historically, Earth's huge polar ice caps acted like a giant white shirt, a massive mirror. Bright white ice has a very high albedo. It reflects up to 80% of the sun's energy right back into space. This is a crucial part of the planet's natural air conditioning system. But as that ice melts, it's replaced by the dark blue open ocean, which has a very low albedo. It acts like a black shirt, absorbing most of the sun's heat. And this creates that dangerous feedback loop. Melting ice leads to a darker ocean, which absorbs more heat, which in turn melts even more ice. The air conditioner is breaking down.
So what does all this actually mean for us, for the billions of people who live near the coast? Let's make this tangible and look at what even a fraction of that 20-foot rise would do to a place like New York City. Computer simulations show this really sobering progression. At just 3 feet, key infrastructure starts to flood. At 6 feet, whole neighborhoods are lost. By 10 feet, the city's arteries, its subways and tunnels are gone. And at 20 feet, we're talking about a catastrophe that would force the abandonment of one of the world's great cities.
And this is not just a New York problem. For a low-lying state like Florida, which has very little high ground to retreat to, a rise of this magnitude would be a devastating, statewide event. This is a global coastal crisis in the making.
And it's not just about slow, gradual flooding. Warmer oceans are rocket fuel for hurricanes. Since the 1970s, the intensity of tropical storms has already increased by about 50%. So when you combine more powerful storms with a higher sea level, you get storm surges that are far more destructive than anything we've ever seen before.
Now I know, this is a bleak picture. It's easy to feel pretty overwhelmed. But history also shows us something else. It shows us that when we're faced with the global atmospheric threat, we are capable of taking decisive action. Consider the story of leaded gasoline. For decades, we pumped lead into the atmosphere from our cars. By the 1970s, that pollution had peaked. Then, science proved it was making us sick, so we acted. We passed laws like the Clean Air Act, we got the lead out of gasoline, and the result was a staggering 99% drop in atmospheric lead. We did that.
And this final quote really says it all. The history of lead proves 2 things. Yes, we humans have the capacity to create global problems, but we also have the ingenuity and the will to solve them once we decide to. We can clean up our own mess.
Which leaves us with this final, crucial question. The science is clear. The stakes are incredibly high. We have faced an invisible atmospheric threat before, and we chose to act. Now we face another. The choice is ours.